Hello everyone, I am Suma Hiramat and welcome back to my YouTube channel. I am Suma Hiramat and I am studying in BSc 6th semester and from Sri Siddheshwar Government First Grade College, Nargund. Here, and my seminar topic or assignment topic is definition of a salt bridge construction and its applications. And EMF of a cell with and without salt bridge liquid junction and potential. This is my assignment topic. Then let us discuss about what is salt bridge or definition of a salt bridge. So here in electrochemistry, a salt bridge is a device that connects the oxidation and reduction of cells of a galvanic cell like a voltaic cell, allowing ions to flow and maintain electrical neutrality, thus enabling the cell to function. The primary function of a salt bridge is to complete the electrical circuit between the two half cells, preventing the building charge in either compartment and allowing the electrochemical reaction to proceed. Here, definition of salt bridge is in electrochemistry. A salt bridge is a device that connects the oxidation and reduction of cells of a galvanic cell like a voltaic cell, allowing ions to flow and maintain electric neutrality, thus enabling the cell to function. Here, salt bridge salt bridge is a device that oxidation ಮತ್ತು reduction ರಿಡಕ್ಷನ್ ಹಾಫ್ ಸೆಲ್ಸ್ನ ಗ್ಯಾಲ್ವನಿಕ್ ಸೆಲ್ಸ್ನ ಆಕ್ಸಿಡೇಷನ್ ಮತ್ತು ರಿಡಕ್ಷನ್ ಹಾಫ್ ಸೆಲ್ಸ್ನ ಕನೆಕ್ಟ್ ಮಾಡಲಿ ಅಯಾನ್ಸಿಗೆ ಫ್ಲೋ ಮಾಡಿ ಮೇಂಟೈನ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ನ್ಯೂಟ್ರಾಲಿಟಿ ಮಾಡೋದಕ್ಕೆ ಸಾಲ್ಟ್ ಬ್ರಿಡ್ಜ್ ಅಂತ ಹೇಳ್ತೇವೆ. ದೆನ್ ದ ಪ್ರೈಮರಿ ಫಂಕ್ಷನ್ ಆಫ್ ಅ ಸಾಲ್ಟ್ ಬ್ರಿಡ್ಜ್ ಈಸ್ ಟು ಕಂಪ್ಲೀಟ್ ದ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಸರ್ಕ್ಯೂಟ್ ಬಿಟ್ವೀನ್ ದ ಟೂ ಹಾಫ್ ಸೆಲ್ಸ್, ಪ್ರಿವೆಂಟಿಂಗ್ ದ ಬಿಲ್ಡಪ್ of a charge in either compartment and allowing the electrochemical reaction to proceed. Then construction of a salt bridge. How to construct the salt bridge? Here, before going to a construction of a salt bridge, I will tell you two types of a salt bridge is there, that are glass tube bridge and filter paper bridge. Here, let us deep discuss about glass tube bridge. Here, what is glass tube bridge? They are generally U-shaped tubes filled with electrolytes. Sodium chloride, potassium chloride and potassium nitrate are generally used electrolytes. The electrolyte needs to be relatively unreactive with other chemicals in the cell and have cations and anions with similar migratory speeds, comparable ions, charge and molecular weight. And also the electrolytes are often held as a gel such as agar-agar. The concentration of the salt solution and the diameter of the glass tube plays an important role in conductivity. Lowering the concentration and the diameter of the tube decreases conductivity. Then second one is filter paper bridge, that they are another most commonly used bridge consisting of a filter paper or a porous material soaked in electrolyte. Here, sodium chloride or potassium chloride are commonly used electrolytes. Electrolytic concentration, porosity and roughness of a filter paper affect the conductivity. For higher conductivity filter paper with a smooth absorbent is used. They yield higher conductivity than rough paper with a lower absorbent. As stated above, a salt bridge's main function is to maintain electrical neutrality between two beakers. To do so, the salt used must be inert. The ions need to move to and forth between the two half cells. Then, unlike other salts, potassium chloride and potassium nitrate are better inert salts, and inert salt is used to prevent the reactions from occurring between the salt and solution, the inert salt potassium. Then, how to construct the salt bridge or preparing a salt bridge? First one, soaking stirring cotton or a paper material in an electrolyte solution. ಫಸ್ಟ್ ಒಂದು ಸ್ಟ್ರಿಂಗ್ ಕಾಟನ್ ಅವರ ಪೇಪರ್ ಮಟೀರಿಯಲ್ ಏನಿರುತ್ತೆ ಅದನ್ನು ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಸೊಲ್ಯೂಷನ್ ಒಳಗೆ ಸೋಕ್ ಮಾಡಬೇಕು ಅಥವಾ ನೆನಿಲಿಕ್ಕೆ ಬಿಡಬೇಕು. Example, for preparing a bridge, take a material that large enough to reach 2 beakers. Place this material in a pool of electrolytes until they get saturated with the solution. Take the material from the electrolytic solution carefully and remove the excess amount of electrolyte. Then second one is preparing gel to function as a bridge. Then preparing for gel, second one ಒಳಗೆ. Then the gel is suspended in an electrolytic solution and they are treated with a buffered solution and heated later. The viscous gel is allowed to be set on a glass plate or a tube. Then third one is working of a salt bridge. The oxidations that occur in an anode generate electrons and positive ions. Now the electrons flow through the wire, then leaving the unbalanced positive charge in a beaker. In order to maintain electrical neutrality, the negatively charged ion moves through the positively charged beaker. Then a similar situation develops in the cathode cell but reverse. Here the Cu2 plus ions are consumed so to maintain electrical neutrality. The K plus ions are migrated into this half cell from the salt bridge, hence the electrical neutrality of the solution is maintained using salt bridge. Then what happens if no salt bridge is used in a galvanic cell? It means without salt bridge. Then a galvanic cell is one where electricity is generated by a redox reaction. A salt bridge plays an important role in a galvanic cell. Let us see what happens if there is no salt bridge present in a galvanic cell. Then first, before wires are connected, the solution in each beaker is neutral, so they have an equal number of positive charges and negative charges. Then the zinc bar will give up to 2 electrons, so that electrons flow to the copper bar. Then so the solution gains a positive charge since zinc loses electrons. Then the copper bar takes the 2 electrons, causing one positive copper ion to leave the solution and accept the 2 electrons. When this happens, an atom of a copper will deposit on the copper bar. Then hence this solution becomes negatively charged. Now there exists a 2 voltage, one between the electrodes and the other between the charged electrons. The voltage between the metal bar or electrode is positive and voltage between the charged solution is negative. So these voltage will cancel out and no current will flow. This proves the importance of a salt bridge in any electrochemical cell or electrolysis.